Hey everyone, and welcome. Let's dive right into today's explainer. We're going to be exploring the nuts and bolts of how artificial intelligence actually processes information. Now, I know a lot of you already follow the rapid developments in neural networks and machine learning, but sometimes taking a step back and looking at the core architecture through a really simple analogical lens is incredibly refreshing. The source material we're working with today introduces this awesome conceptual model named Sparky. And honestly, rather than getting bogged down in the dense math of algorithms, Sparky gives us this elegant, stripped-down way to visualize the complex data processing that powers modern AI.
So, did you know AI is actually a bit like you? It's such a fascinating question because it cuts right to the heart of cognitive development. Sparky is the perfect proxy here to show us that, at a foundational level, AI relies strictly on pattern recognition. Think about how a human brain maps out the world from a super early age, right? We take in sensory input, we observe our environment, and we figure out recognizable patterns to categorize and just make sense of reality. Well, artificial intelligence models, specifically deep learning networks, operate on an incredibly similar philosophy. They just swap out sensory input for massive data sets.
All right, let's jump to our first section, how AI learns. The mechanics at play here are straightforward, but they're absolutely profound. AI learns by parsing patterns, it gets better when we use it, and it literally practices to learn. Behind those simple ideas is the reality of algorithmic weighting and data intake. It's a highly active, ongoing process of observation and repetition. When we say an AI gets better when we use it, what's actually happening behind the scenes is the system is continuously tweaking its internal parameters based on new inputs and feedback loops. Every single query or interaction you make is a fresh piece of data that reinforces or corrects its foundational knowledge. It just grows its accuracy incrementally over millions of instances.
The source material really hits the nail on the head with this quote. AI is a bit like you. It looks at patterns to learn new things. The more it practices, the better it gets. The underlying truth here is that the machine learning process deeply mirrors our own human journey of mastery. Just picture someone picking up a complex skill, like, say, learning to play the guitar. Those initial attempts are pretty clumsy and unrefined, right? But through repetition, noticing mistakes, and continuous practice, those neural pathways in the brain get stronger. For AI, running data through training epochs and actively working to reduce error rates, that's the exact technical equivalent of that very human practice.
Moving right along to section 2, the building blocks. So think of machine learning as the process where structured information, acting like colorful building blocks snapping together, leads to logical outcomes. This metaphor is just a fantastic way to visualize the data engineering pipeline, because in the real world, raw data is often just a chaotic, unstructured mess. We're talking unlabeled images, random text logs, disjointed numbers. It's pure scattered chaos. But through algorithmic observation and processing, the AI categorizes and structures all that information. It effectively turns those chaotic variables into distinct, colorful blocks, snapping them together into stable models that can generate highly logical, actionable intelligence. Which brings us nicely to section 3, practice makes perfect. If you compare a student mastering a skill alongside software processing data, the connection drawn by the source material is deeply, incredibly accurate. The way a large language model or a computer vision system processes information requires a sort of consistent mechanical studying. The software doesn't just look at a dataset once and boom, achieve flawless comprehension. No way. Instead, it runs that data through countless iterations. It makes a logical guess, measures exactly how far off it was from the correct answer, adjusts its internal weights, and then tries again. It is literally a rigorous mathematical version of a student drilling flashcards late into the night before a huge exam. And by keeping up that persistent, iterative practice, the technology successfully moves beyond basic categorization and actually begins identifying complex patterns. This is the crucial leap, guys. It's where a system evolves from just recognizing hard-coded rules to genuinely understanding nuances. Finding these hidden, complex patterns within the data architecture is exactly what allows modern AI to accurately predict user behavior, parse the semantic meaning behind natural human language, or even spot microscopic anomalies in medical scans. It is all about finding the intricate relationships hidden deep down within those fundamental building blocks. Let's see how this all comes together in section 4, the iterative journey. You can distill the entire life cycle of machine learning into a really clear, momentum-driven loop. Step 1 is continuous interaction, which creates a steady, flowing stream of fresh input. Step 2 uses that input for identifying complex patterns, mapping out relationships and probabilities. And Step 3 is the payoff, gradually improving accuracy and performance over time.
This continuous three-step loop is the absolute driving engine of artificial intelligence. The interaction feeds the pattern recognition, which refines the algorithm's performance, which then allows it to handle even more complex interactions down the road. So, bringing together everything we've explored today leaves us with a few vital takeaways. The evolution and capability of AI are entirely driven by continuous interaction. Without fresh data, the whole engine stalls out. It relies fundamentally on observation and pattern recognition to make sense of the world, super similar to human cognition. And ultimately, its primary function is taking the sheer chaos of raw inputs and transforming that structured information into highly precise logical outcomes. Which leaves us with this. Since AI is on a continuous journey of observation, what will it learn from interacting with you next? It's a genuinely provocative thought, right? Because every prompt, every interaction, and every little piece of feedback we provide becomes part of that iterative loop. If practice and interaction are what ultimately refine these models, it is definitely worth considering what specific patterns your unique data will teach artificial intelligence tomorrow. Thanks so much for joining me to explore this fascinating breakdown today. Keep observing the patterns around you, and I'll catch you on the next explainer.